Hi, my name is Marta, and in this video I will explain geometric sequences. A geometric sequence is a sequence in which to get to the next term we always multiply by the common ratio, by a number which is the same, always the same for a sequence. So if I have a sequence, the first one here, I start with 2, so the first term is 2. And then to get to the next term, to the next number, I multiply by 3. To get to the next number, I multiply by 3 again. To the next one, multiply by 3 again. The rule is always multiply by 3, so that's a geometric sequence. The first term of this sequence is 2, and this number we multiply by is called the common ratio, denoted by letter R, and in this case R is 3. Okay, let's take a look at the next example. I'll just make more space. Oh, maybe like this will be better. Okay, so in the next example, is it a geometric sequence? Let's check. The first term is 27. And now, how do we get to the next term? What do we have to do? If we multiply always by the same number, it means that it is a geometric sequence. Well, to get from 27 to 9, we actually have to divide by 3, but it is fine, because dividing by 3 is the same as multiplying by 1/3. So yes, actually this one is also geometric, because to get to the next term, we always multiply by 3. By 1/3 this time. So the common ratio in this case is 1/3. Let's take a look at the next example. In the next example, to get to the next term, we have to multiply by -2. 4 times -2 is -8. -8 times -2 is 16. 16 times -2 is 32. So since the number we multiply by is always the same, and it's -2, the common ratio is -2, and it is the geometric sequence. Okay, let's try to figure out what the general formula will be. I will copy one of the examples one more time. Let's say the first one. It's an easy, nice example. 2, 6, 18, 54, and so on. And I need a formula because if I want to find the 100th term, I don't want to multiply by 3, by 3, by 3 till I get to 100. I would like to find a nice trick. So let's try. The first term is 2. Now, how do you get to the second term? Well, to get to the second term, I have to multiply the first term by 3. So it's u1 times 3. Okay, now, how do you get to u3? u3, so the third term, 18. How do we get there? Well, I have to multiply 2, so the first term, by 3, and then by 3 again. So I actually multiply twice. So that is 3 squared. How do I get to u4? u4 is 54. And again, I have to start at the first term, and then I have to multiply. Let's see how many times. Okay, let's see. I start at 2, and to get to 54, I actually have to do times 3 to get to 6, times 18 to get to 8, times 3 to get to 18, and then one more time times 3 to get to 54. So I had to multiply by 3 times. So I had to multiply by 3 to the power of 3. Should I do it? Okay, let's just do it one more time. Let's just do it one more time just to make sure that everyone sees what the formula is. So to get to u5, I would have to take the first term. I start at 2, and I multiply 2. Here everywhere u1 is obviously 2, but I will just make it clear, even though I wrote it here, just to make sure that everyone sees it. And to get to u5, so here, I have to take 2 and multiply it by 3 to get to 6. Then multiply it by 3 again to get to 18. Multiply it by 3 again to get to 54. Multiply it by 3 again to get to the 5th term. So in total I had to multiply the first term by 3 to the power of 4. 4 jumps to get from u1 to u5. So 4 times I multiply by 3. So the 5th term will be 2 times 3 to the power of 4. So that's 162. And let's say that I would like to find u100. So let's observe what the rule is. To get to u2, I had to jump one time, so that's times 3 to the power of 1. To get to u3, I had to jump 2 times, from u1 to u2, u2 to u3. To jump to u4, I had to jump 3 times. To jump to u5, I had to jump 4 times, right? So, if I want to find u100, I have to start at u1 and multiply by 3 how many times? It will be 99 jumps. If I start at u1 and jump 99 times, I will end up at u100. So let's calculate it. 2 times 3 to the power of 99. Ooh, that will be a huge number. But it's okay, let's calculate it. Let's use a calculator. 3 to the power of 99, and that to the times 2. Oh wow, it's a lot. It's 3.4 times 10 to the power of 47. I don't have enough space to write down this number. I will just leave it like this. So the nth term in general, the nth term, if I want to get to the nth term, I have to start at u1 and multiply it by my common ratio, r, whatever r is. R represents this jump, this common ratio. It was 3 in this example, it can be anything else. And I have to jump from u1 to n minus 1 times. Right? If it was 100, I had to jump 99 times. If it's n, I jump n minus 1 times. That's the rule. So this is the general formula for a geometric sequence. That's how I represent any number, any term in a geometric sequence. It is always u1 times r to the power of 1 less than the number of the term. Okay, let's try to solve examples involving this formula. Let's just grab this formula with us. We will need it. Okay, this formula we will just grab and drag to our next example. Where is our example? Here it is. So I have to find an expression for the nth term of the geometric sequence 3, 12, 48 and so on, and then find u100. Okay, so I will use, I have to find the nth term, so un, and I need to complete the formula. u1 is first, u1 is the first term, and in my case I know that I start with 3. The first term is 3, so I always start with 3, and then I multiply that by jumps, the common ratio, so 1 jump. In this case, what do I multiply by? I can see that my jump is 4. I multiply by 4 to get to the next term, so my common ratio is 4. Now if I want to create the nth term, I know that I have to jump by 4 n minus 1 times. So that's the formula. 3 times 4 to the power of n minus 1. So if I want to find the 100th term is, I have to start at 3 and then 4, I multiply by 4 99 times, 100 minus 1 times, so that's the 100th term. And that's a big number, so let's just leave it in this form. Okay, let's take a look at the next example. The second term of a geometric sequence is 4, and the fourth term is 8. Let me write it down. The second term is 4. It's a geometric sequence. Geometric sequence is also called geometric progression and denoted GP for short. So this is a geometric, so there will be a common ratio involved. The second is 4 and the fourth term is 8. Given that the common ratio is positive, find the exact value of the 11th term of the sequence. Okay, so I don't know the common ratio, I just know it's a positive number. And I would like to find the 11th term. To find the 11th term, I think I will just use the formula. Let me copy the formula one more time. Un is u1 times r to the power of n minus 1. Okay, so u11 will be u1 times r to the power of 10. Lovely. But I don't have u1, I don't have r. I have to get them first, somehow. But I know that the second term is 4 and the fourth term is 8. And just observe, if the second term is 4, and I know that to get from the second term, I have to multiply to get to the fourth term, I have to multiply the second term by r 2 times. So the second term times r and times r again, so times r squared, is the fourth term, right? Second times r is fourth. If I substitute what I have here, this and this, so I have the 4 is r, u2 is 4, u4 is 8, I get that r squared is 2. That means that r has to be either root of 2 or negative root of 2. But I know that my common ratio is positive, that was given, so I will erase that minus. I know that it has to be positive. Okay, so the common ratio is root of 2. And now I can just use this form. Well, it's up to you. I could just jump from the fourth term to 11th, or from the second term to the 8th one, or I can just finish as I started and find the u1 first, even though I didn't have to. But okay, let's find u1 just to practice, and then find u11. Okay, to find u1, I will come back here where I have that u2 is 4. u2 is 4. u2 is 4, but I don't know u1. But that's okay. To go back in a geometric sequence, I have to divide by r. Right? To go to the next term, I multiply by r. To go to the previous term, I divide by r. So u1 is the second term divided by r. Or in other words, I know that if I multiply the first term by r, I will get u2. These two are equivalent, but it depends how you understand it. So u1 is the second term, so 4, divided by r, and r is the root of 2. I could rationalize the denominator, but I'm not going to do it because I don't really have to. It will simplify here anyways. When I calculate u11, u11 is the first term which I calculated, that it is 4 over root of 2, times the common ratio which I calculated, that is this root of 2 to the power of 10. So basically I substitute what I got. 4 over root of 2 is u1 and r is root of 2. And based on that I calculate u11. Okay, let's do it then. I can simplify this power with this root. Root of 2 to the power of 10 divided by root of 2 is simply root of 2 to the power of 9. Now I have to find the exact value, so I don't want to round it, I just want to leave it in terms of roots. But maybe let's just simplify it a little bit. It is 4 times and root of 2 to the power of 9 is root of 2 to the power of 8 times root of 2. I will just try to simplify it in this way. And then root of 2 to the power of 8 is the same as, oh, you can use a calculator to find it, or you can just understand that you have root of 2 times root of 2. Oh, that's a lot of writing. Or you can just maybe write down that root of 2 is power of half and use the laws of powers. Half times 8 is 4. What I'm trying to say here is that root of 2 to the power of 8, since root of 2 times root of 2 is 2, is the same as 2 to the power of 4. So that's what I end up with. 2 to the power of 4 is the same as root of 2 to the power of 8. And 2 to the power of 4 is 16. 16, and 16 times 4 is 64, if I calculate it correctly. Let's just check it, just in case. 2 to the power of 4 times 4 is 64. Okay, I was right. So 64 root of 2, and that's u11. That's the 11th term. Since I had to give the exact value, I will leave it like this. I won't round it or anything like that. Okay, so that would be the answer. Is there anything else I had to find? No, that's it. Okay, so that's u11, that's done. Let's move on to the next example. In the next example, in the last example for this video, the numbers 3x and x plus 6 form the first 3 terms of a geometric sequence with all positive terms. Find all possible values of x. Okay, so we have a geometric sequence, geometric progression, with terms 3x, x plus 6. And we know that all the terms are positive. It's good to know. That automatically means that all of those are positive, so x has to be positive. And we have to find the value of x. So I would just use the relations between those terms. I know that if I multiply 3 by r, I get to x. So 3 times r will be x. But on the other hand, if I multiply x by r, I will get to x plus 6. So x times r is x plus 6. That's what I know about a geometric sequence. To get from the one term to the other, I just multiply by r. I don't know r, but it's okay. Notice that, let's just notice here that r, because of that, is x over 3. So in other words, to get r, to get the common ratio, I have to divide 2 consecutive terms, the next one by the previous one. So just observe that x divided by 3 is r, is the common ratio. The same with x plus 6 and x. The common ratio is x plus 6 over x. So in other words, I know that if I divide x plus 6 over the previous term, so x, I get the common ratio. So what I'm trying to say here is that these two are equal. If I divide the second term by the first one, it will be the common ratio. But if I divide the third one by the second one, it is also the common ratio. So these two are equal. The second term over the first one is the same as the third one by the second, because both of those are common ratios. They are the ratios between the terms. So all I have to do here is to write this down and now solve it. I can perform the cross multiplication to solve it. X times x is x squared. 3 times x plus 6 is 3x plus 18. And now I end up with a quadratic equation. Fortunately, if you are in the chapter sequences, that means that you have learned how to solve quadratic equations before. So I won't bore you with explanation of how to solve a quadratic equation right now. I will just quickly solve it using the quadratic formula. Why not? I mean, you can use whatever method you want to use. I will just be very straightforward and use the quadratic formula. So the first solution I get from the quadratic formula is 3 minus 9 over 2, which is minus 3. And the second is 3 plus 9 over 2, which is 6. Minus 3 and 6, that matches the formula. Okay, so I got my x's. I got two options because I solved a quadratic equation. So I actually got two options. I got that x is minus 3 or that x is 6. So which answer is correct? Are both correct? No. No, it was given here that all the terms in a geometric sequence are positive. So x cannot be minus 3 because that would mean that this second term is negative. So I will ignore this solution and write the proper final answer, that x is 6. So that is the final answer. We found x as we were supposed to, but I will show you here just to explain what we got. What geometric progression we got here. The first term was 3, the second x, so 6, and the third one x plus 6, so 12. That's what we ended up with, a geometric progression. We had to figure out x, and to figure out x we solved a quadratic equation in the end. The main thing here was to understand was this, that in a geometric progression, if you divide u2 by u1, it's the same as u3 by u2, because that's the common ratio. So this is how we solved it. That would be the last example for this video. See you in the next one.